Hey, I'm going to try this video again. I keep getting interrupted. So let me take this from the start one more time. So graphing polar equations can be pretty challenging for students because, again, it's a very different way of looking at things. And it's also just wrapping together all those different trig pieces that we have been doing over the span of the semester. So what I think I'll do is I'm going to take it back from scratch and just do 4 different pieces and try to really very carefully link all those pieces together. So let's take it from this first problem right here. I want to graph 10 cosine, 10 plus 2 cosine theta. So I'm going to think of this more like 10 plus 2 cosine x and go back to the beginning of the semester. So keep in mind, if it is 10 plus 2, it's got that amplitude of 2. So it's going to go as high as 12 and as low as 8. We can cut them across right here. Now, one of the things about the symmetry that we get to experience in here is that we know that this graph has very, very nice x-axis symmetry. So because it has x-axis symmetry, if I could graph quadrants 1 and 2, then I can use their mirror image to go ahead and execute what happens in 3 and 4. So let's go ahead and put r and theta, and we're going to go ahead and grab a few values in quadrants 1 and 2. So I'm going to start right here and know that at angle 0, it had a radius of 12. Now, I personally love to add pi over 3s to the cosines because the cosine of pi over 3 is a half. It's the only rational number we have. So the cosine of pi over 3 is a half. Half of 2 is 1, so we would have 11. Then I'm going to grab easy numbers here. Pi over 2 gives us 10. I'm going to keep going to 2 pi over 3. Now, the cosine of 2 pi over 3 being in the second quadrant is also 1/2, but it's negative 1/2 because it's in the second quadrant. So half of negative 2, that'd be negative 1. So this is going to dip down to 9. And then by the time we reach the angle pi, it's gone all the way down to a radius of 8. And this is getting me the first 2 quadrants. So if I go ahead and just plot these values, so here's the first one, I'll call it A. B right here is 11 at pi over 3. Then it dropped down to 10 here at pi over 2, down to 9 at 2 pi over 3, and down to 8 at pi. So let me see if I can make this actually come pretty nice. Kind of challenging to make it look really good. That's not too bad. And then I'll go ahead and use a little bit of symmetry argument. So I know if this value is at pi over 3, then I know that same value is down here at 5 pi over 3 because that nice little x-axis symmetry. I've got this 10 at pi over 2, so I've got another one here at 3 pi over 2. 2 pi over 3, I'm going to make it down here to 4 pi over 3, and there we go. That is my nice little graph of my limacon. And notice that it has a maximum radius of 10 plus 2, which is 12. Again, looking at this thing, the maximum radius of 10 plus 2 is 12. The minimum radius is 8. And you'll notice the 10 shows up on the off radius. Now, I did go ahead and graph it in Desmos itself. So you see the 12 here, the 10, and the 8. So you can see those, but having that extra value in the middle right here helps an awful lot to kind of just clean up the graph and make it look just that much nicer. Okay, moving on to my second graph. My second graph here is to take a look at 6 minus 4 sine theta. So again, I'm starting off at the value 6 right here, and it goes up 4 and down 4, like that. So it's got a maximum radius of 10 and a minimum radius of 4. It's a sine, so sines have nice y-axis symmetry. So really what I would like to do is graph quadrants 1 and 4 and then allow that to inform me about 2 and 3. So again, going back to this, here's r and theta. So keep in mind when theta started at 0, the radius is right here at 6. Similar to the cosine, I'm just going to use one number in the quadrant to help me out. And the sine of pi over 6 is a half, and a half of 4 is 2. 6 minus 2 is 4. So it's coming down a little bit. And by the time I reach pi over 2, I got as low as 2. Now keep in mind, this is quadrant 1. I'm kind of done with that. So now I just want to take a little bit of quadrant 4. So for quadrant 4, just like before, I do know that 3 pi over 2 is the same as minus pi over 2. So that's going to be in quadrant 4 right down here, and the radius grew as high as 10. And one more value I'm going to pick is negative pi over 6, also known as 11 pi over 6. And so that is where the sign, remember the sign, all students take calculus, where the sign is negative. So if the sign is negative 1/2, I've got a double negative, and so I actually get negative 4 times negative 1/2, which is 2. I got 8. And now I'm ready to go. So I have 6 at angle 0, 4 by the time I reach the angle pi over 6. I'm all the way down to 2 by the time I reach pi over 2. I'm at 10 out here at 3 pi over 2. And I'm at 8 at 11 pi over 6, also known as negative pi over 6. So if I play connect the dots, I guess I'll call these D and E, but it doesn't matter. So if I play connect the dots, it's getting bigger and bigger and bigger and bigger. And you'll notice, as you should have predicted, it is bigger going down because of that minus sign that's connected to that. Now keep in mind, we can use a little bit of symmetry. So I'm going to take this value right here and I'm going to slide it over to the same place over in this quadrant. So it's right here. I'm going to take that value, slide it over to here, and the number at 11 pi over 6 is going to match the number at 7 pi over 6, which again is also going to be 8, and I could just kind of go like this. Now that graph is looking almost like a cardioid, but it didn't quite reach 0, which is why it's technically not a cardioid. Now that is a pretty decent graph, but of course in Desmos you can see this is a slightly better version. It's a lot more smooth, of course. Desmos has plotted not 8 points, they plotted hundreds of points or thousands of points to make it really clear. Now we're going to go a little bit further. This is our first cardioid. I'm only going to do one cardioid. Notice it's a cardioid because it has a minimum radius of 0, goes up to 16, and then back down to 0. This is going to have x-axis symmetry, and it should be pushed to the left. So again, because it has x-axis symmetry, what I'm going to choose to do is I'm just going to look at quadrants 1 and 2 and allow 1 and 2 to inform me about 3 and 4. So again, just like we've been doing, let's go ahead and start at angle 0, and you can see that we have 0 as a radius, and you have that on the graph. Pi over 3 for ease. Half of 8 is 4, so 8 minus 4 is 4. By the time I reach pi over 2, the graph right here says that I should have a radius of 8. So there it is. There's 8 with an amplitude of 8. Then 2 pi over 3, the cosine of 2 pi over 3 is a negative a half. So I have a negative 8 and a negative half. You might notice that it's growing. The radius is getting bigger and bigger and bigger to the point that when it reaches pi, it's grown all the way to 16. And you can see that, see? Everywhere from 0 all the way to pi, the radius is getting bigger and bigger and bigger. And so if we plot 0, 0, 4 at pi over 3, we plot 8 at pi over 2, 12 at 2 pi over 3, and 16 there at pi. The graph is getting larger and larger and larger until it ducks over here. And then just, of course, a little symmetry. Let's take this value right here at pi over 3, and let's follow that down here into 5 pi over 3. Let's take this pi over 2 right here at 8, and let's drop it down to 3 pi over 2 at 8. So there's my nice symmetry. And one more, let's take the 2 pi over 3 at 12, and let's put that same thing here. And so now we can kind of do a reasonably decent job. And that's a cardioid extended to the left. And of course, one more time, I've got a really nice, pretty looking version of a cardioid down here. Notice it's got this maximum radius of 16, and it's got these middle values. Give me one second.
I'll be right there, John. Got one to go.
Okay. And our last example is right here. And that is, this is one of those graphs that's going to have a little bit of a loop in it because it actually has a chunk that is negative. So keep in mind, it goes as starts at, I guess, 6, has an amplitude of 10. So all of this information is here. So again, it's a sine. So I'm just going to graph quadrants 1 and 4 and use a little symmetry to get me there. So here's r and theta. So I know at theta equals 0, the radius started at 6. Again, I'm being pretty redundant here. I'm going to pick pi over 6 because the sine of pi over 6 is a half. Half of 10 is 5, so that's going to give me 11. By the time I reach pi over 2, the radius has grown all the way up here to 16. By the time, let's see, I guess I'll go ahead and I'm done with that part. Let's go ahead and consider the fourth quadrant. So let's grab negative pi over 6, also known as 11 pi over 6. The sign is negative down here, so that would be negative 1/2. So that's going to give me negative 5. 10 times negative 1/2 is negative 5. 6 minus 5 is 1. Wow, that's a tiny little radius. And by the time that I reach the number 3 pi over 2 or negative pi over 2, the radius is dipped all the way down to negative 4. So that's going to be interesting. Like, how do we put all that together? So I started at 6 at angle 0 right here. 11 by the time it reached by the time it reached pi over 6. It got all the way up to 16 by the time it reached pi over 2. So it's about like this. And let's go ahead and sketch this up. I have to get over to help another teacher with something, so I got to wrap this thing up. There we are. And now let's get a couple of points. We've done these 3. I just need this one. 1 at negative pi over 6 is down in here. It's just going to come down like this. I call this maybe point D. And then at 3 pi over 2, it should be down. It told me to go backwards. It's right here. But it has to, and by the way, that's a critical part of your graph, it had to somewhere pass through 0. So don't let it miss that 0 point, and this is what the graph looks like. Hopefully that was helpful to you to kind of see how that plays up. Again, let me pull this back down so you can see how those things go together. But notice that it didn't miss that. It didn't go straight from -1, straight from 1 to -4. It actually had to pass through 0 on its way. Notice the loop because there was a region where the graph was negative. I'll see you back on a separate video to go over roses. Have a good one. See you soon. Bye-bye.